have in NetLab Ulrik, who's the IT architect, who it's possible to borrow Ulrik for some time to get some help with your projects. And as part of that, we enjoy using these NetLab forums to kind of discuss the progress of the project, and sometimes not as much progress as we'd like, but then it's really good to have a forum to also discuss some of the challenges here. So this project about the history of tracking on the Danish web basically asked questions about when and how different tracking technologies has been used on the Danish web, and trying to look at the reach of some of the companies like Facebook and Google Alphabet to see how prevalent is it. And then also trying to look at how different technologies for e-commerce have been used, and some of the main companies involved in that. And we also think that there's both a relation between e-commerce and tracking because of the business nature of tracking as well, but also because we're expecting that some of the methods we're using to study the one could also be useful for the other. And I'll get back to that. It's also part of a larger project where I'm trying to study some of the implications of tracking on the Danish web historically. So I'll also be looking a little bit at the current extent of tracking on the Danish web, mostly to try to compare with what we see in the historical records. And also I'm very interested in aspects of privacy and consent in relation to that. So I'm also looking a bit into cookie notices and GDPR and issues relating to that. So basically interested in seeing how this tracking landscape has developed and some of the implications of that. It's also very much related to a large and ongoing, and for some years now, running project about the history of the Danish web domain that I'm doing with Niels and Ditte and Askov and Pierre from the Royal Library have been involved, and Ulrik is involved. And we're looking at how the Danish web have developed from 2006 to 2015, and trying to analyze this historical development using a lot of different what we call probes, where we try to look at all these different aspects. How could we learn more about the historical development of the Danish web by doing a lot of different analysis? So we're trying to do some different time slices, and we've been lucky to get some pilot projects at the HBC facility, Dijk National Cultural Heritage Cluster at the Royal Danish Library, to be able to run these different analyses. So basically, we have made a corpus from each year, trying to make like a, so you guys know about web archiving and the difficulties of that. So, making a snapshot is not as such possible, but we're trying to make a selection so that we get as close to what would have been a snapshot. So for instance, we don't have a lot of the same objects several times. So that's what we're trying to do over the years. And then trying to do all these different analysis, looking at the measurements based on the crawl log data, so the metadata about the crawls. We're looking at link analysis based on data from the Solar Index, and the tracker analysis that I'm talking about today is based on some of the different archived sources and text analysis and more analysis to come. So trying to make these different entry points. So I'll say something about this tracker analysis here today, and because that's the project I've been working on now with Ulrik. But it's in the context of this bigger project, and the whole way that we're doing this corpus creation has implications for the different projects as well. So basically, when I talk about web tracking, I mean different techniques for collecting data about users and their behavior online. And this can happen across websites and devices. And it has a lot of different purposes also historically. So, and some are more, what's the word? Some of them are necessary for the way that we are used to using the web today and experiences the web. So for user identification and authorization, and some are more
about web analytics, trying to optimize web usage and things like that. And some are related to the whole advertising industry and trying to build these profiles of the users that can be used for behavioral targeting and things like that. So that's things like if you search for a couple of boots, and then all of a sudden you will have advertising for boots everywhere. So this way that the tracking is also has consequences for the content that you will see online. So the idea is to try to, and this idea is inspired by Anne's work, actually, among some other work, and the idea of looking at the source code to find traces of some of the technologies that may have not been archived as such. So we ask if can we use the code layer of archived websites to find traces of this tracking. And the idea is to try to identify different trackers and try to find their like signatures or fingerprints, the different characteristics that they have, and how that can be, how we would be able to find that in the source code. So this, for instance, up here is, I don't have a mouse. Oh yes, I have a mouse here. Is a Facebook beacon. So that would be how that would have looked in the source code at a specific point in time, and then see can we find that. So try to find the traces of tracking in the source code by looking for these signatures. And there are a lot of different tracking technologies in use on the web, and they apply different techniques. So it's also different sources that we need to try to look for these different types of technologies. So that's also part of the work, finding out what types of archive sources do we have and where would we be able to find these traces. And then using the corpora from each year that I described, and try to create scripts to search for and extract these traces of tracking. So that was kind of the basic idea. And there are a lot of different challenges to doing that. And one of them is trying to identify all the different types of tracking, and also finding out whether those types of tracking even leave a trace, because it's not necessarily something happening on the client side. And also historically, how can we see what trackers have been in use over time? How can we find that information? And then, of course, designing the methods for trying to identify them. And this again speaks to some of the troubles that have been mentioned already today about some objects and technologies that are difficult to archive. So it's also a project about trying to look at, when we're trying to study something that is not what is usually considered the content of a website, so the content that we want to have in the archive, but something that's part of this whole environment around the website. Then we encounter an issue that this is not usually what's the focus of archiving. So there's a lot of it that might not have been archived. But again, trying to look at the source code may be a way of getting around these issues, because we don't necessarily need the for instance, we don't need to see the specific cookie, but we need to see something that tells us that the cookie would have been set on the website, for instance. And then there's the issues of assessing the impact of changes in archiving strategies and settings over time, because of course the archiving is not one thing. The scope and settings and technologies used for the harvesting itself has also changed over time. So when we see changes, how do we know if there are changes in the archiving settings, or if there are changes of what was actually out there? So to try to find some of these signatures, we also use the Archive Web to try to look into sources like Facebook describing how they know this is not that page. This is actually a blog where someone has looked at the Facebook beacon, which is the beacon is one of the technologies we're looking for, and has kind of deconstructed that script to say this is a technology, here's what it does. And then we can find information in there where they make like a code walkthrough, and then we can see, okay, so this is the signatures that they found. So at this point in time, this would have been it, and we can try to look for that. But also as Anne also mentioned, they describe a lot on their own websites because they make this available to developers and website owners that they can, if you want to use the Open Graph protocol, this is what you do. If you want to use the Facebook pixel, here's the code that you need to add to your website to use this. So this gives us some of the signatures that we want. But of course, this is not necessarily available for all the very, very many technologies out there. So we're also trying to figure out how could we have ways that could be not only looking specifically for, we can try to track the development of Facebook and Google over time and then look for those. But if we want like a more broad picture, how do we do that? Can we find a technique that kind of identifies some of this? So the approach that I will talk about now is the first one where we've kind of gotten results, and those are very preliminary results because we've also seen some new issues when we get the results. But this is a technology called the Web Beacon or WebBug, and it's a 1x1 pixel image file used for tracking. And this is one of the technologies that has been in use for a long time and still is in use. So it's one that should hopefully also allow for us to have like a historical view over how it's been changed. And so basically I was trying to make like, so if this is a website, there would be somewhere on the website, there would be a small pixel. It would be much smaller than this, obviously, and it would be transparent mostly, so it wouldn't be visible to the user. But if we then look at this would be an example of a very simplified example of the source code, then we would be able to see the script in there that would signify that this beacon has been on the page. So the idea is to where is this? I think I've lost a slide. One second. That's annoying. Oh, this system, it's difficult to. Okay, and then I'll just say it. So the basic idea is to try to combine two ways. So we're looking at the HTML code. So we have from the WARC files, we have the HTML document, and we look through the source code for in this case we look for image tags. So that's why this is not the best example for this, because this example here would require that you look specifically for the Facebook beacon, but you would have a lot of the ways that the web beacon would be used would be having, you would have an image and you would have the URL that this image is then served from. That would be in the source code. So you could look for that third-party URL in the source code, and if it's related to an image tag. Does that make sense? And then we took from Solar, which is the full text index that has all that is used for full text search of the archive, and has metadata about the files. So we can use from the Solar index information about which images are 1x1 pixels. So we can search by that and see which images match this size that we're looking for, and then we can merge that information. So we get all the images that are requested from a third party and that has this size. And then of course we cannot be completely sure that this is used for tracking, but that's would usually be the case, that if you have a 1x1, other studies show that if you have this type of beacon, it's used for tracking. And then of course we have to kind of look more into that, whether that makes sense then when we actually get the results. So these are the first results where we try to take the top 25 of what comes out of the beacon domains. So that is, beacon domains are the domains that has that serves the beacon. So this is not a website that has the beacon on it, but the domain, that's the server that serves the image. Does that make sense? So you can see, if you look at the top one at 2006, Danzig.dk has a beacon on 3,283 web domains. So that's the way. So then we can start looking into it, and we see that some of it is definitely tracking, some of it is counters, type of like early, more like how many has visited your website, and some of it is more like what we would consider more advanced tracking today. And some of it is also CDNs, content delivery networks, and so there's a lot of areas that we have to try to search, like how do we even define what it is. But then we can kind of look at the developments over time, and we have to combine this quantitative access or like approach with the qualitative analysis to try to figure out what is it actually that we see in these numbers. And there's a lot of things related to that as well. For instance, we can see that some domains change their names over time. So if we look at Danzig again, then that's the topmost in the 2006 and 7, and then all of a sudden it's gone. So that's maybe surprising. It's not in the entire list at all for the other years. It's not just because it's below 25. But then by looking at all the websites in these are from the Internet Archive, and we can try to figure out qualitatively what type of page is this. Is it a tracker type thing? But also figure out if there are issues like in this case where we can see that the one that is, maybe you can guess which one because it's colored the same color. So er.dk is actually Danzig's new URL, so that is the same. And we can also try to look into, so it didn't just drop out of the list, but it did after that. We can also try to look more into what of the companies that are, or the tracking domains that are actually related. So if we look at, for instance, Google, they have a lot of different domains that they use for tracking, and we can try to see how can we map that to kind of more show the reach of a company like that, because they also have DoubleClick, for instance, and applied semantics. And so if we need to get a picture of that, we need to also do a lot of research on which companies are actually related. And then there are the additional things of some of the companies might also sync identifiers or other things, or might share data in other ways, but we can't see that from that. But of course we need to be aware of that. But these very early visualizations also show that there might be some issues with the data. So for instance, it's quite surprising that we have this very large increase in Google Ad Services here in 2012. And it's even more surprising because the general picture of the size of the Danish web looks like this, which we're also addressing right now because we realized that the drop in 2000, so this is the one of the other probes, and it shows the size of the Danish web. And when we saw this, we needed to look into what happens in 2011 and 12, because this is based on the first broad crawl from each year. And we realized that the first broad crawl in 2011, NetArchive respected robots texts. So for that, it's not a very good. So now we're running it again with a new, the second broad crawl from 2011, and 2012 has something to do with global filters being implemented. So we're looking into whether we should kind of change the basic corpus that we build it on. But looking at this, it's also surprising that why is it then? It's maybe it's even larger in 2012. Another thing is, so this is the Facebook beacons that I've mapped, and that shows like that would be something that like what I would expect. But then if we look at the numbers, it's surprisingly low, because you can see it's only 600 and something, and I would expect it to be all over the web at this point in time, especially if I look at some of the small pilot studies that I've been doing on the current Danish web. I've just run one in October. I didn't have time to include the numbers, unfortunately, but we can see at least from this that we would expect Facebook technologies on a lot more of a larger proportion of the sites, because here we see that it's around 60%. So 600 on the entire Danish web, that's quite low. And actually the same for the Google beacons, because that's also, it's 20,000, but it's again, it's for the very high peak. So we need to figure out why are there so few, and it might be that only the big web sites have beacons. We can see that from the some of the other measurements that the Danish web has a very, very long tail structure. So you see relatively few very, very large domains, and then a lot of very small domains, and people's own personal websites and things like that. So and a lot of the tracking studies that have been done, that show very, very huge prevalence of Google especially, but also Facebook, are usually done on the top popular websites. So maybe we see this huge percentages, and that's the same that I did in the current use on the Danish web. I took top 180 websites. So maybe it's because it's mostly in use on the big websites. Or maybe they're using other technologies, because of course we're trying to look at a lot of different tracking technologies, and this is just the first one. So it might just be that they're using other technologies for tracking cookies and HTTP cookies or flash cookies, and they can be using canvas fingerprinting or some of the other ways of tracking. We also have to ask ourselves if we're not finding all the beacons, of course, with our approach. Is there something that should be amended here? And what could be the possible reasons for this if we're not actually finding it? So again, this brings us back to the very in-depth knowledge that is a necessity for about the web archive and the archiving process that is necessary for this, because we actually realized from looking at this beacon study that the way that we're creating our ground corpus, or like our basic corpus that we use, the snapshot thing that we use to select all the sources from for the different analysis, is based on the crawl logs. So the crawl logs is the log of the log of what happens during a crawl. So when we started looking at this and we said, why are there so few beacons? We're looking even more into this, how this process happens, and we see that there's a module in the heritage harvester that's part of putting URLs forward to be harvested. And it turns out that one of the ways that this is, it's called the frontier, one of the ways that this can be set up is that it only allows a URL to be put forward for harvesting once in a job. So if we have, for instance, if we would have 20 URLs that are on the seed list for a harvest, and all of them have the Facebook beacon, and the Facebook beacon with the exact same URL, this URL would only be put towards the frontier once, possibly. And then it would only be crawled once, and then it would only have one line in the crawl log stating that we tried to harvest this object. So when we then base our analysis on a selection algorithm running on these crawl logs, then we run the risk of not knowing that this Facebook beacon was actually also on additional 19. So that kind of that's something that comes about that we didn't know for the other analysis, and then we now have to address: was this the module that was running, or was it something else? And if it was, how widespread implication does that have for the numbers that we have? And it's not an issue for all the analysis, because in this case it's we would expect that because we're looking at the HTML, we would still have that. We would have the information in the HTML about the beacon, but the problem is that if this HTML document has not been selected as part of our corpus creation, then we don't know. So does that make sense? So we have to run through like the whole process and see, is something left out during the process? Yes, and what does that imply? So, but I also think, first of all, we see that it's possible to use the source code to find these types of traces of tracking, and then we have to assess that. And we also see that this way in the project of kind of doing all these different probes is useful for us for a broader understanding of the material that we're working with, because we can realize new things when we apply different approaches. So, but and the last, I want to mention additional changes, that it's very difficult to try to do a project like that, because the whole getting the data out and cleaning the data are extremely time consuming. So when I was preparing for this, I was looking through my old applications for this IT developer support to have like for some weeks to help out. And I could see that in the beginning, all we wanted to do in the first 4 weeks, right? And then we got a little bit of the way, and then what we wanted to do for the next 4 weeks. So for me as a researcher who's not proficient in writing these scripts and knowing enough about the technical detail, it's very challenges to have this dependency on IT consultancies, both because I have different people involved for different tasks. So I have had Asger at the Royal Library help out with the process of extracting and transforming and loading the data and helping with some of the scripts, but then that time ran out, and then I've had Ulrik working on some things, but then that time runs out, and I still need to, because it's so complex, we find new things all the time that we need to address, and then I still need to be able to run the scripts. I need to be able to change according to what we find and develop in response to that, and so we need this knowledge exchange and documentation. And it's also, I think it would be very interesting in this forum and with other who's using Ulrik to also try to get together some of our ideas about how to make a process like this, where you're on one hand really dependent on this help and get great help that is very useful, but also how do you handle this process of working together, which is really great, working with the IT support and the archive curators, but it's also a challenge. Yes, thank you.